In this video, we want to look at the concept of a simultaneous equation. This is a situation where we have two equations and we want to solve them at the same time. So we recall that if you have something like this, supposing you have x plus 2 to be equals to 5. This is an equation in one unknown. This is one unknown. And for you to solve in the sense to get this value of x, you will be given only one equation. So here we have only one equation. So we are familiar with handling this kind of equation. But if you have something like this, supposing you have x plus y to be equals to 5, and I tell you this is one equation again, here we have one equation. Now, supposing I tell you to find the value of x and find the value of y, this is absolutely impossible because you cannot find the two unknowns in one equation. So for you to find two unknowns, you require two equations. So now, to find two unknowns, you require two equations. Just like we have x minus y, we are looking for x and y. So for you to solve this kind of equation, you will require another equation. So now, with that, I can have something like this. Maybe I can have, let's say, 2x plus 3y, maybe to be equals to 8, for instance. So now I have two equations. Now it makes sense for me to find the values of x and y. So now I have x and y. These are two unknowns, but these two unknowns in two equations. So in general, to get any unknowns, you require n equations. This kind of equation, now, finding the x and y, you have to solve the two equations at the same time, and that's what we mean by being simultaneous. And this kind of equation you are solving at the same time is what we now refer as the simultaneous equation. Furthermore, there are various methods one can use to solve this kind of simultaneous equation. You can use graphical method, you can use method of substitution, and you can also use the method of elimination. So in this particular video, we'll be paying attention to the method of substitution. So that's what we'll be looking at now. So we are kicking off now with this example. The example says solve the equations. So we are solving these equations. So now to do that, we are looking at the solution. So remember that solving these equations, what we need to do is to find the values of x and y. So now you rearrange this equation. So you have x minus y is equals to 3. You call this one equation 1. Then the next one you have x plus y being equals to 5. And you call this equation 2. So we have now two equations. Then, before I go further, one might ask, when do we use this method of substitution? It is advisable to use this method of substitution when one of the coefficients of the unknowns is equals to 1. For instance, the unknowns in this equation is just x and y. The x and y, these are the unknowns. So if just one of the unknowns now has a coefficient 1, then it is safer to use substitution method. For instance, you know that x has a coefficient 1 because x can be written as 1x. Okay, therefore, now the coefficient is equals to 1. So it is enough to get one of the unknowns, the coefficient of the one of the unknowns to be 1. So when such happens, it is now safe to make the use of a substitution method. Okay, now what do we do to make that substitution? You can either start from equation 1 or equation 2. There is no rule here. You will start from the equation of your choice. Now, supposing we decide to start from equation 1, so we are here. So we are now at equation 1. Then, what happens is this. From that equation 1 you have chosen, you want to start with equation 1. The method of substitution says that you should make x or y the subject of the formula. So the choice is yours again to make one of the unknowns in equation 1 the subject of the formula. Supposing I decide to make x subject of the formula, I now say from equation 1. So now from equation 1, so what happens? From equation 1, I'll make x the subject of the formula. And if you make x the subject of the formula, this becomes that x is now equals to 3 minus y crossing over the other side becomes plus y. So now, let's call this equation, let's maybe call it equation 3, for instance. We will now see where the name substitution comes in. So what we are going to do is, we are going to substitute x is equals to 3 plus y. So we now go to equation 2. Any place we see x, we put 3 plus y in equation 2. And that's where that name, substitution, comes in. So now what do? I will now say substitute. So substitute is just like replacing. That's what it is. That is another word for it. So you substitute x equals to 3 plus y. Remember, we are going to do that in equation 2. Reason is that the x is coming from equation 1, so you're not going to substitute it in equation 1. It will not make sense. So what happens? You have to do that in equation 2. So you have to substitute x equals to 3 plus y in equation 2. So if you make subject of the formula in equation 1, you substitute in equation 2. So the question says substitute x equals to 3 plus y in equation 2. So I'll go back here. So any place I see x, I will put 3 plus y. That is the idea. So now, in equation 2, I have x there. Instead of writing x, I'll write 3 plus y. So this 3 plus y has taken care of x. So the next thing is I have my plus y. This plus y now. So I have my plus y. Then everything is equals to this 5. So being equals to 5. Now, at this point, we have come back to what we are familiar with. So this becomes a single equation. So by collecting like terms, you have 3 plus. So at this point, you have y plus y gives us 2y. So I have 2y, everything being equals to 5. So we're not done yet. So this is where we are. So here, collecting like terms, you see, we have 2y here. So we're going to take this value here to be with the numerical value there. So if you do that, so that will give us, on the left hand side, you have only 2y remaining there. So 2y is on the left hand side. Then on the right hand side, you have 5. Then 3 coming over there becomes minus 3. So we have 2y to be equals to 2. So remember, what we are now doing, we are now solving for y in the usual one equation method. So now what happens? You divide both sides by 2. Divide here by 2. So that here, this 2, cancel this 2. This 2 cancel this 2 to be 1. So what have we got? We have gotten that y is equals to 1. But we are looking for x and y. So we have found y. So we need to go and find x. Another substitution we go. So to do that now, for you to find x, you substitute y equals to 1 in any of the equations. You have equation 1, we have equation 2, and there's another equation we came out with, equation 3. So you can substitute in any of the equations. But if you look at the 3 equations, you find out that it is safer to work here where we have 3 plus y. So remember in equation 3, you have something like this. X being equals to 3 plus y. So this still remains our equation 3. So you can substitute there. So you can substitute y equals to 1 in equation 3. Or you can do that in equation 1 or equation 2. It doesn't matter. But I think it will be easier to put it in equation 3 so that we can get the value of x directly. So we'll say substitute. So substitute is just like saying put y equals to 1 in equation 3. So let's see. So equation 3 is x. So x is equals to 3 plus y. Now instead of writing y, I will now write 1 because y is equals to 1. So I now have that x equals to 3 plus 1. So what do I have? I have x is equals to 3 plus 1 is equals to 4. So what I have gotten is this. I can say therefore now that x is equals to 4 and y is equals to 1. So therefore now I have gotten the two values, or rather the two unknowns